All right. Welcome to the Shop Class Podcast. Tonight we got a special guest, Vince from the Coffee Stream. Literally a coffee trailer, like a food truck with really good coffee, except this is unique. In this situation, Vince has gone off grid as much as he can. So he powers all of his equipment silently with a battery. Instead of, most food trucks have on the side of the vehicle, they put the generator. And why is this good for shop teachers? Well, you could have an off-grid system. Maybe you're not next to the classroom. Maybe this is the future. Maybe everybody's going to have batteries instead of generators. Maybe every house will have a battery instead of a generator. So let me introduce you to Vince. Vince, how you doing?
I'm doing good. Thanks for having me tonight.
All right. And we got Al, upstate New York. Damien, he's in the future. He's in the next day. Australia. We got Tim, New Jersey, Northwest New Jersey. We got Duke, East Stroudsburg, Pennsylvania. We got Nick, upstate New York. We got Matt Bloomquist in Illinois. All right, cool. So I always start with the first question I always ask everybody. Vince, did you have shop class growing up?
I did. I actually, high school here in the city I grew up in wasn't really an option. It's a kind of rough neighborhood. So I went to a county high school. It's called Bloomfield Tech, where my brother actually went there also. He took welding. My father kind of pushed me in, and I took electricity for 3 years going through high school.
No kidding.
No kidding. So I did all kinds of Romex projects, all the way up to bending EMT and putting it into circuit breaker boxes.
Oh, wow. Okay. Now, forgive me. Romex is like, is that the boxes?
Romex is your typical house wiring. It's the yellow and white coated wires that carry 120 volts to most receptacles.
And how did you guys do it in the shop? Did you have like a pretend house that you would wire up?
So there's a few different methods in the shop. When you walk into the shop, it's a long hallway, probably about 30 or 40 feet. Both sides are covered with plywood, 8 feet up. So you get like a wall, like a plywood wall you can screw anything to, okay? Then once you got into the shop more, there's a tool crib to the right. There's an array of wooden workshop desks. And the teacher sits at the front, and then just past that, there's a wooden framed house. Just frames, though. No drywalls hung, no sheathing on the outside, just a framed house.
Cool. That's pretty cool. Vince, we got a connection issue. Okay. There you go. You're back.
Yeah.
Okay. Yeah, there you go. You're back now. So you're actually.
So
yeah. Go ahead.
So we learned electrical theory starting off and learned how to wire in a receptacle. Well, I think one of the first things we learned was how to strip wire. Then we learned how to wire a receptacle, and we had a 4 foot by 4 foot 2 foot by 2 foot project board, and we had to do all of our things on there, like wire a receptacle to a switch and wire in three-way switches, all kinds of stuff on one little board to make a light bulb light up. We did that for about 2 years. And then our senior year, we started moving into houses and wiring in the house. And once you completed the house, then you'd move on to the wooden hallway, the one that you walk past every day going into the shop. And as a sophomore, I'd see all these seniors' projects on the wall. There'd be pipe bent up, all kinds of offset bends, 90s. And so you work your way up to the wall, which is kind of like top dog for electrical.
Oh, that's actually pretty cool. So like the senior projects are hanging and you're kind of like, yeah, it's like what you strive for. That's pretty cool.
Yeah, exactly. So you have to walk through it and see it every time you walk into the shop.
Wow. And then what was your final project?
I don't remember what my final project was, but I believe if I had to take a guess, I think it'd be hanging a circuit breaker box where they all go in, and EMT had to run into the box from all different kinds of bends, and you had to wire up the box to different
And
outlets along
what's
the
the
wall.
EMT? Is that the conduit?
EMT is electrical, metal, something like that. But yeah, it's conduit. It's just metal conduit. But the hard part is like bending it to the proper shape.
Got it. That's awesome, man. That's really good that you learned all that because you definitely applied it in this situation, right?
Yeah, and that's only like scraping the barrel as far as mechanical knowledge.
Nice. That's awesome. Uh, any other areas that you picked up some of this knowledge?
Yeah, all over. I mean, growing up, my dad's a master plumber. He's got every license except for electric, which is kind of why he pushed me to do electric. So I grew up, I mean, since I could hold a hammer, I grew up working on stuff. Building stuff, like actually just before this, maybe 2 hours ago, I'm rebuilding the back wall of my garage, putting in new headers and stringers.
No kidding. That's awesome.
So I've held multiple mechanical jobs, all kinds of stuff.
Okay, so now how did you get into the coffee business?
That's actually a funny story. So my career prior to the coffee business was I actually managed an auto body for 3 years.
Oh, no kidding.
Yeah. So I managed an auto body for 3 years, and it was kind of like I walked to work. My boss kind of like had me in a good spot, and he didn't want to give me fair pay. So I already had the trailer. This was already like going on in the back of my head, and that was kind of like the icing on the cake to quit. So I quit and started working on the trailer full time. When I quit, the trailer was just an empty shell. I had just got the shell back onto the frame, but there was nothing in it, no insulation, nothing. So I worked through the winter doing the coffee business, and I just wanted to start a business. My girlfriend wanted to start a coffee shop, so here we are.
Oh, okay, that's awesome, man. Yeah, and like it doesn't look like you just threw it together. Like it looks legit. Like it's a great looking trailer. It's well put together. Like it's attractive. Like I knew right away. I actually saw that I think somehow I was going to a car show and I saw your coffee trailer as promoted, and I was like, I definitely want coffee.
I try to promote some of our stuff.
Yeah, because you were at the show. Yeah.
I don't know how many people it reaches, but I try to promote where we're going.
Oh, here's kind of some behind the scenes, right?
Yeah. So originally you see there's a small little window there, and we had to cut it and make a serving window, which was a task in itself because I had to bend 1.5 by 1.5 aluminum tubing, which I'm sure you guys know isn't an easy task.
Yeah. It's you kind of then. Oh, this is good. Wait, how long did you do the auto body for?
I was the assistant manager in the auto body shop for 3 years, but prior to that, ever since I got my license, I mean, when me and my buddy, maybe our second car, we bought matching cars, and I put a lightweight flywheel on my car one day when the rear main seal was leaking. I didn't like the way it felt driving the car; like there wasn't enough momentum to keep going. So we pulled both of our cars in my yard, and we pulled engines, swapped flywheels, and put it all back together the same night. So and that's kind of like we started turboing our own cars, just however we could do it. But yeah, ever since I got my license, so like 11 years now, maybe even longer, I've been wrench on vehicles, and before that, mechanical construction stuff.
Wow. When did you get the Airstream?
I got the Airstream a little over a year ago. I got it. I remember I was on vacation July 4th week, and we went and purchased a trailer. The guy was about to ship it off to Europe. So that picture right there, we had just got everything out of the trailer, and a lot of these guys, they use a gantry lift to lift the shell off the frame. And when we got it, the the metal support right by the door was actually rusted out. He tried patching it and all kinds of stuff. But yeah, I rigged up a gantry crane to the tree and used that to lift the shell off, and then pulled the frame out. And there was a lot of frame repairs. Yeah, somebody
So
actually came to buy parts off me, and they said, "I bet you could rig a gantry crane up to that tree." So I did it with 2 chain hoists and a 2x6 on the interior, 10-foot long 2x6.
this is awesome, man. I've never seen that before.
So it was a
Yeah,
process.
why
Our
not?
neighbors were like, "What's going on back there?"
That's hilarious. Yeah, there's a building right there.
Yeah,
You're in a
yeah,
you're in a like one of the neighborhoods that has houses but also buildings.
yep. There's a supermarket across the street. It's a very urban area.
Yeah. Man, look at this frame.
Yep.
Okay. Now, but why did you get it? Like, why did you want an Airstream?
Well, this was early COVID. We started looking, and we're like, well, let's just quit our jobs and travel the country, like everyone else's thoughts during COVID. I mean, not everyone's thought was let's quit our jobs, but everyone's thought was, hey, I can work remotely. Let's travel.
Yeah.
So, but my girlfriend and I, we both hated our jobs at the time. So we were like, let's buy a trailer and travel. Then my buddy had like one of the RVs that's like connected to like a van chassis. Not the new van ones you see all the place, but like the old '90s ones. So we were gonna buy that. Then I was really thinking about my options, and I said, hey, let's get a trailer. Maybe we want to move somewhere. We can leave the trailer there, and work. We'd have the trailer's home base, and we'd have a vehicle, so you can kind of like establish like roots there, and you can like move into a place without having to pay for rent or anything. You have to pay for your parking spot for the trailer. That's it.
Right.
So we thought about that, and I started looking for Airstream trailers because I know it's an iconic trailer, but also if you look at any 20-year-old RV, they're all falling apart because they're built like crap. They're disposable essentially.
Mm-hmm.
So, but the Airstreams, because of the shape of them, they're not really disposable. And I looked at the values too. The value, they don't really drop. I mean, they drop from their initial value, but they kind of plateau to like a steady value. So I paid $5,000 for the trailer empty, and like I said,
Wow,
the guy was
that's actually pretty good. These are sought after.
Yeah, exactly. And like I said, the guy was going to ship it to Europe. So I figured just right there, just buying the trailer and reselling the trailer, I couldn't lose.
Wow, no kidding. That's awesome, man.
Then we watched a video on some guy turned a larger one into a coffee shop, and we said, let's do that.
Oh my God, this is how it started?
That's how we got it.
Dude, you did a lot of work. It does not look like this now. That's amazing. Oh man, this is cool. So then, yeah, so then you went from, all right, we're going to travel, but you need a business. And you're like, okay, how about we make a coffee trailer?
Yeah. There's more complications too. Like I can't really move out of the city of Orange currently because I'm waiting to get into the fire department, and there's a lot of, that's my old Comanche that I had. I actually sold that thing to finance building out the trailer.
Nice. That's a good, I like the Comanche. That's cool. That's rare. We don't see too many of those.
That thing had 35,000 miles on it. Original
Oh my God.
miles. It was sitting on a farm for 13 years. I got it, tore everything apart, repainted the whole thing. That was a great truck.
This is the better half.
That's the better half.
That's cool. You guys are having fun. Like this is cool. Like you got a challenge. You're like, all right, we're gonna do a business. We're gonna do it our way. That's awesome, man. All right. So then yeah. And this is you guys cleaning it up.
Yeah, this guy had it sitting in his driveway for
Oh my God, look at all that dirt.
Yeah, 5, maybe 10 years. There was bees nests in it when we got it. Birds were living in it, rodents, all kinds of stuff. It was in his driveway up next to like a bush. And this guy's wife must have hated him. Next to a bush. It was backed up to his garage door, and there was like a little like 3-foot path to get into his garage. and there was scrapes all along the side where you could see he kind of like brushed up into his garage and kind of like scraped it going in. So that picture right there, we took the shell off. I think September 1st we took the shell off and started on the frame. It took probably about 2 weeks to get the frame cleaned up and like ready to like get the subfloor on. And then the subfloor was a task in itself because the guy attempted to patch the subfloor himself because it was all rotten, but I didn't have anything to go off of because he cut out the rear curve section. So I was looking online for dimensions, and I used the track that the body actually sits into to replicate the curve on it. And I actually, in the rear part, I actually messed it up a little bit and made the curve too big. So when I went to set the shell back on, it wouldn't fit.
Wow, this is interesting. Yeah, you basically did a restoration and an upgrade and everything.
Yeah. So in that picture, we had, I mean, we got the frame, and then we put the subfloor on, and then I was calling buddies over all the time to help me flip this frame because I needed to work on the top side and at the bottom side. So by the time the frame was ready to go back in, I called everybody that's like ever helped me like do anything on the trailer or like came to drink at my house. And I was like, I really need you guys today. And it was a crew of like 10 or 13 of us, and we all flipped the trailer for the final time and took a picture.
Wow, that's cool. Oh man, this is a great story. What now how did you lift the body? Is there points that you thought like you can't just lift from one point, it would tear itself apart? Like how do you grab it?
Let me figure out how to flip my camera here. Okay. All right. So we're in the trailer now. There's actually 3 vents that came in this trailer. This one, there was an air conditioner in, which is now our only working fan sucking out. And then there was this vent here, which came in the trailer, and there's another vent back here. So the vents that come in these,
Vince,
it's a
hold it.
rapid vent.
Vince, hold it horizontal. You get a better view. Yeah, much
Work?
better. 1,000
So
times better.
that vent. This was an air conditioner hole, and there's this vent. So the vents that were in there were actually, the edges were rounded. They're really expensive. So I knocked the things out, and I put a chain hoist right here with a 2x12 going across all the way to this back vent, and a chain hoist coming through here, and then the body just lifted off. A lot of people brace these things sometimes. I didn't do any bracing on the inside. A lot of people spend, I mean, partly because of the cost of lumber, but partly because it's like another week of work. They'll spend a solid week bracing these things so the ribs don't move at all when they lift it. But I just put the 2x12 in and lifted it up. I was pretty confident in my abilities to get it back on.
That's awesome. All right, so and then we're gonna get to the part with the batteries, but before we get to that, can you give us like a coffee tour? Kind of like how?
So the trailer's kind of
give us
right now. A pipe broke the other day in here that I didn't attach correctly. So you walk in the door. I have our low boy fridge right there. We have our eco coffee brewer to use as little battery as possible. We have hot pots to keep the coffee hot so we don't use power when we're not brewing coffee. Smallest grinder we could find that does the job. Then we have our espresso machine. This thing pulls the most power, 20 amps at 120. It's kind of it's a big machine. We got a pitcher rinser, ice bin, in-counter ice bin, 3-bay sink, hand wash sink, and here's our serving counter right here with our window that just pops out, and it's actually got lights on the window also.
Oh, nice.
And then so there's that. And then as far as the mechanicals, we have our 70-gallon waste tank right here.
Uh,
You guys can see
little
that.
little bit of a reception problem, but okay, we're back.
All right. There's a water trap right there. Drain lines come in from the pitcher rinser. Ice bin has a drain line, which you can't see. The espresso machine has a drain line. There's a water filter up right there. I don't know if you guys can see. It's kind of like the crack of it.
Yeah.
And there's a vent pipe, actually, that's hidden within the walls of the trailer. It goes right up this wall. You can see a little bit of it right here, kind of pops out. But I actually used Bondo to fill that in, so you don't see any cracks or crevices, and it worked out perfectly.
Wow.
And then we get to the actual working parts of the trailer. Up here, I have just figure out how to hold all this crap. Up here, I have a 55-gallon freshwater tank that's centered in the trailer on the tongue of the trailer. So when I'm towing, when I'm loaded up, I keep the tongue heavy so the trailer doesn't fishtail. So there's freshwater tank. Over here, the freshwater tank comes to a 24-volt water pump, and this is just like it's an air tank, so the pump doesn't cycle so much. So it'll keep pressure up to 65. It pressurizes up to like 65 psi, then it drops down to like 50 before the pump kicks on. But I mean, without that tank, it's very common for the pump to like not stop cycling. And then the whole electronic side of the trailer is we have our battery packs right here. 1, 2, 3 24-volt battery packs. We have power coming into the trailer. There's actually 4 coming into the trailer. So I have it right now set up to charge off 120 volts. But the wiring's in place to charge off split phase electricity if I choose to do so. So electricity comes in, it goes into the inverters, which then invert it to DC voltage. And then these inverters are actually on right now. Even though they're not on, they are on. They're in standby mode, so they only charge. They send the power back out to the batteries when it's time to use the batteries.
What's the name of those inverters again?
These are MPP solar inverters. And they're like this is like the common stuff for off-grid guys.
Right.
This is the go-to, you could say. Like, this is the Milwaukee of power tools.
Okay. And what's your? Oh yeah, go ahead.
Everybody in the off-grid community uses these inverters. They swear by them. Nobody really reports any problems with them, and so that's why I chose these. I was doing research on inverters for at least a month.
Nice. Now, what's the how many watts can you get out of your situation there?
These will push 4,800 watts continuously and surge up to 5,800 watts, I believe.
That's a lot.
So yeah, 40 watts. It's I'm kind of pushing close to that much wattage when I turn everything on in the morning, because like the espresso machine takes 2,400 watts. The hot water heater down there takes close to 1,500 watts, and the coffee maker takes I think 1,400 watts, and the fridge takes like 500 watts. So I really have to, in the morning times, I have to watch what I cycle on. Like I can't turn on the hot water heater, espresso machine, and the coffee maker all at the same time.
Got it. This is like awesome. What a cool setup. Yeah, so like Bloomquest, are you watching this?
Yeah, man, this is awesome. This is so cool.
Because Bloomy, he's a teacher. He's got an off-grid situation because they do construction, and so they could be. They're not near the school, so they got to get power from the street, but it's temporary. But before that power shows up, they don't have any power. So it'd be great to have a trailer with power, you know.
Danny, what do your neighbors think of you?
My
You have,
neighbors have no idea what I'm doing over here. My
Wow.
neighbors have no clue. One is one of them moved in last year. He doesn't speak much English. He does construction. The other one, we don't really talk to them, but they don't really say anything though.
Yeah, that's because you have a trailer hanging from a tree and batteries going in and out of your yard. I
They
don't
have
know
no
if I'd
idea
say
about the
that to
batteries.
you
They just see
anyway, either.
I mean, they're usually annoyed at us anyway because we're always doing something. But can I just got to get some water really quick.
Yeah, go for it. Go for it. Yeah, take your time. Yeah, pretty cool setup, so now think about it. He's got the lights on and everything. And he's got the lights on, no noise at night. He can run anything he wants. What a cool setup.
See, we have a coffee shop just like this in our town. It's called the
Okay.
Coffee Can. I think they run off of. So they're sitting in a business parking lot, and they're right next to a building. And I gotta believe they are hooked up. I don't know. Maybe they're not. I've never asked them, but they did Airstream coffee, like a drive up coffee thing, just like this. So it's pretty cool. Like, but I don't know if they're technically like off the grid. I think they're plugged into the business that they're like connected with or whatever.
Right.
But watching him do all the tear that thing apart, it reminds me a lot when we had to tear ours apart to build the mobile classroom, man, tearing it all down. And now, granted, we didn't keep anything, so we were able just to demolish, but very cool.
You had to find someone to do some English wheel work to get the aluminum panels. There was some curved panels. Yeah, some of the curved panels, well, they're compound curves.
Yeah.
Those weren't, they were rotted out or something. He had to get new ones.
That's awesome.
Yeah. When he gets back, we'll get into the build of how he did it.
Now, are they aluminum?
Yeah.
Are they aluminum or stainless steel?
Aluminum.
I think aluminum.
Probably aluminum.
They're aluminum.
I have my grandparents' 53 Airstream 40-footer.
Oh,
Dang.
no kidding.
Have it?
Dude, we go to Nick's. We could all sleep at Nick's.
Yeah. No kidding.
The idea is, part of me wants to get rid of it. Now I see this, and maybe I don't. There's a restorer.
At least
right here.
not for a low ball price anyway.
Vinny, what year is that?
This is 67.
And it's all aluminum.
Yeah. The shell is aluminum. The frame is steel.
Hey, Tim, remember Joel from school? TCNJ, he had the mustache. He was a Navy guy. He was an older guy, too.
Yeah, I think I remember. Tall, thin guy.
Yes, he always talked about his Airstream
Yeah.
trailer. I always wonder what happened.
He was the career college kid, I think. Because he was there. He took like one class a year.
Yep.
And was doing construction on the sides or something. And but I don't remember him talking about the Airstream.
Oh, yeah, he used to talk about it all the time.
I don't remember that. That was one of those things that the Airstream, I didn't start getting into them until about like 10 years ago, and just like kind of noticing them on the road or noticing them on the side of somebody's yard and things like that. That's before that. I had no idea what they were, but now I just look at them and like, those are really cool. They really are.
Oh yeah. Well, so they're, from my understanding, it was somebody who worked in the aircraft industry and applied the same techniques for making wings into a trailer because he knew that the trailers were like bricks and they had no aerodynamics. Am I right about that, Vince?
I'm not exactly sure. All I know is the guy's name was Wally Byram. And I think it started in like the 30s or 40s.
That's cool. And is there like registration? Is
Yeah, there's
like
a registration. There's a VIN number on this thing too. It's really weird though because it's only like 6 digits. Whereas most vehicles have like 17-digit VIN number.
And they're still around. I sat inside of a modern day Airstream.
Oh
The
yeah, they're
small-
still around. I actually met. So we did an event in Lime Rock racetrack in Connecticut. Where I actually met the old CEO of Airstream.
Oh wow,
He was
no
the
kidding.
CEO of Thor Industries. Yeah. So he was very enthusiastic about the trailer.
Oh, that's cool. So
But yeah,
this is the
Airstream's
one.
still around and they're doing well.
They're killing it, and they make a modern day miniature. And I've been inside this one. You see this one here kind of looks small.
Yeah.
No way. It
Now
is
it feels much bigger on the inside.
Yes, maximum potential. Like take a look. You got see the configurations. You got your table. You got your. Let's see if they got more photos. I guess just that. But like, here's your bathroom, a full bathroom, a sink, and like a kitchen area, and then a sleeping and eating area, and it's all within this tiny little thing.
And you know, too, they're pretty lightweight because of construction. It's just the aluminum skins and the ribs.
Yeah.
Versus a different kind of trailer. I mean, they're built out of wood.
Right.
They're built out of wood and disposable materials are built out of fiberglass that's gonna break in 20 years. It's gonna get a stress crack in, and now you have to rip the whole side of the trailer apart.
Oh yeah, this is true. Freaking cool, man. So all right, so that's kind of the situation with the Airstream. Let me go back and I think we got to be able to find the original, like how did it start? You know. Let's see. Here we go. Airstream. Bam. Yeah, Wally. Thor Industries. Oh, 1920s. Really? It's created by Wally Bam. Began building trailers in Masonite in his backyard, Los Angeles, during the late 20s. Wow, no kidding. I didn't realize that. That's interesting. Cool stuff, you know? And is this your model right here?
No, that's actually, that one's got another axle. I'd like to have that model. That's like the most sought after model they make, or they made.
So by this point, yeah.
That looks like mid 60s, judging by the front rectangular window. But the ones that are around 20 feet long with a dual axle are highly sought after because you don't feel like you're towing this massive trailer. It's only 20 something feet, so towing this thing around is really not bad. But I'd like another axle, so that one's kind of like the most sought after model.
At this point, with all your knowledge and experience, would you just build your own, or would you still go with the shell and retrofit it?
What do you mean build my own?
Like if you wanted this other axle or you wanted to upgrade in some way, would you just make your own trailer? Or would you still get a shell?
That's a tough question. I mean, if I was to do it again, I would not get another trailer.
You would just make it from scratch, right?
No, I'd get a van.
Oh.
Yeah, I'd get like an old step van. I mean, it kind of seems like cut and dry, like every other food truck. But
yeah,
in a practicality sense, it's way more practical. The trailer's not very practical. I mean, it is. It serves as like a home base. If I had somewhere to park it, it'd be phenomenal. But actually, getting on the road with it, bringing it places, it's not. When we get somewhere, everything's everywhere on the inside of the thing. As many bungee cords as I put and screw stuff down and put eye hooks and everything's everywhere still.
Wow, no kidding. All right, so let's get into the battery. So, you know, let's start with like typical setup. Somebody would definitely like just bring a generator with them, right? That would be the normal way to go, right?
Yeah. So we were looking at that as an option.
Now, what made you think about the battery?
Because the generator is $6,000.
Okay.
That's a lot of money for a generator. So, for what do you want for a generator on a food truck, right? You don't want to be able to hear it because they're noisy. They're really noisy. So you need a quiet generator, okay? Second thing, you need a lot of wattage to run all this equipment. And third thing, you want reliability. So what are you looking at? Are you looking at the Harbor Freight or the Honda?
Right.
Harbor Freight just came out with a new generator. Cool. But last year when I built this, they didn't have that generator. So the Honda was the only option. 7,000 watt surge, 6,000 watts continuous, I believe. So that was my option, but $6,000 brand new. Even used, they're $4,000. And the pitfalls to a generator, you have to put gas in it every single time. You have to maintain it by changing the oil, changing the spark plugs, changing the air filter, stuff like that. And it's probably 200 pounds that you literally have to pick it up and out of your truck bed or something every single time and connect the cord, and just, it's more of a hassle.
That makes sense. Yeah, that's how I see it too.
So I started looking at battery systems because I knew batteries were coming a long way, and I thought about lithium. I thought about lithium-ion batteries like a Tesla. So I started researching batteries, and I found out that lithium-ion batteries are really not the kind of batteries that you want to run, because they don't really have a long duty cycle. Well, I mean, the first one you find is a lead acid battery, and those are horrible battery. I mean, back in the day, yeah, cool, but now they're horrible batteries. They're horrific. You can only use maybe 50% of the available power within the lead acid battery. They're heavy, and you need to carry a lot of them, and it takes a long time. They're really good for high discharge scenarios like a car. That's why they still use them. But in terms of energy storage, they're garbage. And then you get into lithium ion, which is a step above. Well, no, after lead acid, it's absorbed glass mat, just one step above lead acid. Yeah. Then you get the lithium ion, and so lithium ion, you get, I think you get like 1,000 cycles or something like that per battery. That's like discharge and charge cycles, but they're not very stable. They can catch fire. You can overheat them. And once they start catching fire, they're it's kind of like a runaway.
Yeah, they have their own electrolytes, so it's like their own oxygen, I heard.
Yeah. And you can't discharge them to the floor either.
Right.
So I was doing more research, and I found lithium iron phosphate batteries, LiFePO4. Yeah. And I did my research on them, and certain lithium iron phosphate batteries have a life expectancy of 3,000 to 5,000 cycles. Oh, you have?
I got one here.
You have a massive battery right there. Is that 200?
This thing is 280 watt hours.
That's a lot.
Yeah, this was $350, and I have to have 34 of them. Yeah, 34 of them for the Fiero.
It's a lot of battery. But so I looked up the lithium iron phosphate, and I discovered that they're a very stable battery. Yeah. I looked up the data reports from the company that made them. They drove nails through them, they crushed them, and they don't catch on fire. They actually still discharge after they crush. I mean, not what you would expect, but they still discharge. People report all kinds of just nothing but good about the batteries, except that they're very expensive.
Mm-hmm. I have a example here of the the companies that sell them. Like this is the company that I had to buy mine from because I needed this exact model to match the stuff in the car already. I didn't buy all those batteries. It was in the car. But what's cool is that these guys do their own testing, which then you benefit from because they have a YouTube channel, which I'll turn off the sound so that I don't get a copyright strike. There we go. And if you go to their testing, let's see, if you go to videos, you can watch them test the cells. You can see they drive a nail through it. Oh, here's when there we go. So this is them doing, there's an advertisement here. It's unbelievable. Okay. Yeah, so battery testing, here we go. And let's see, overcharging, short circuit, mechanical damage, and ignite. Those are pouch cells. This is, I don't know which one. Oh, here we go. That's my type of battery. Those must have been, I'm not sure. I think, okay, overcharging. Here we go. We're not going to watch this whole thing. I'm just saying it's great that they do the testing for you. You know?
Yeah, they do the testing, and you kind of like see what actually happens.
Here we go. This is shorting out like a phosphate cell, and they might swell, but they don't go on fire.
Yeah, correct.
And that's a big deal because you got this at your house. You're worried. You're relying on it for your business.
That's a really big deal because when a battery catches on fire, you're not putting it out. You have to let it burn.
That's right. The fire department can't put it out. Here's an example. They already hit this thing with a, I don't know what they punched it with, but they punched it with something. Yeah, it's gassing out, but it's not catching fire. And then I guess this would be, they dump it into, oh, there we go. So these are all three different types. LFP, lithium iron phosphate, got hit with the axe or whatever, and then it just won't go on fire. They even hit it with a torch in one scene. Here they go. They're hitting it with a torch. And they're actually trying to light it on fire. And sure, the plastic goes up.
But not the actual chemical makeup.
Yeah, that's just plastic on fire, which is that will go out.
Yeah. So,
yeah.
In terms of
the disadvantage is it doesn't have as much energy. It's heavier.
the LiFePO4, that it's got energy in it.
Oh, okay. All right.
I mean, I think there's new battery technology that has more stored energy, but the lithium iron phosphate stores the most energy of batteries. But they're very expensive. So initially, I was looking at buying them used. Used batteries there's a huge market for used batteries. They're in server racks all the time. And yeah, they're in medical equipment, and the batteries come out. They go to these guys like Battery Hookup, where they get them and they salvage them and they sell them to people. So they actually have really good prices on like lithium iron batteries. They're like phenomenal prices, but they're heavy and they're not safe. And they're already about 70%. They only have about 70% life. So you're essentially, I mean, in my situation, I would be carrying around that's the battery I have now. That's a top band.
This one.
3.2 volt top band, 25 amp hour pack. So I got mine for a phenomenal price. I actually have a little battery pack I built from like old medical battery packs that has like a BMS in each cell. But so I had to learn about BMSs and cell voltage, linking cells in series and in parallel, stuff like that.
So just so everybody knows, battery management system, BMS, that's basically so that if one cell's up, one cell's down, it actually balances it by shaving off some power from the high cell. That's from my understanding. It depends which system you have.
Yeah.
Cool. Okay. Yeah. So you had to get into this whole thing.
I had to join battery forums and watch tons of YouTube videos just to because I mean, this is a whole new thing. It's like diving into a new field. And I had nobody to even tell me about it. I kind of just had to watch YouTube videos. So this guy on YouTube, Will Prowse, is very, he's got a lot of information. So I watched that guy's videos and learned a lot about batteries.
That's awesome. Will Prowse, yeah, he's good. He's like the traveler, right?
Yeah.
I'm gonna try and find him. How do you spell his name?
Will, Prowse.
Okay. Oh, here we go. Yeah, this is it.
That guy, you can learn a lot from that guy.
He's pretty
about
thorough.
inverters, solar panels, and he breaks it down for you. He tests stuff.
Yeah, this is good stuff right here. So you're YouTube certified.
Oh yeah, yeah. I've been on YouTube since it came out. I learned a lot of stuff from YouTube.
Yeah, and you know he's real thorough. Like he goes through the whole system, like everything you need.
Yeah.
Yeah, this is a good one. And also since he's pretty popular, I think a lot of companies send him stuff to test out. So he's got all the latest stuff and he tests it out.
Yeah, they send him all kinds of stuff. So like that inverter, I was looking at inverters like that, but they're not. Most of them are not pure sine wave inverters. There's different categories of inverters. There's modified sine wave and a pure sine wave inverter. Modified sine wave is like getting power from like an old school generator where it like comes in like phases. Your lights will like flicker, but a pure sine wave it gives you good clean energy. And so a lot of these coffee machines are real finicky and they won't work on unclean power, so to say. So you want like a really good power source coming in. So that's why I chose these inverters as well. He had them on his channel. He recommended them.
You know what's funny? When someone says clean power, like it sounds funny, right?
It does sound funny.
Yeah, but the power actually is a wave, so you got to have a good wave. Otherwise, you could damage equipment, or like you said, if you got sensitive equipment, it doesn't want to work.
Yeah, exactly.
That's cool. So, all right, Case. So you went down the rabbit hole, and these are some of your photos in early on. So you got a whole bunch of these. This is like wow.
Right.
Look
That's not even all the batteries. That's the cells for one pack. That's 64 cells. I was trying to figure out how to arrange them in a way that would work for my cabinet where I was putting them, but also to be able to link them up to get 24 volts. Each cell is 3.2 volts, 25 amp hours. So if you combine 8 in parallel, you bump the capacity up and not the voltage. So when you put 8 in parallel, it bumps it up to 3.2 volts, 200 amp hours. And then when you put them in series, it multiplies the voltage. So 8 in parallel is 200 amp hours. So there we go. I got my 200 amp hours.
That's 8.
Then,
so a pack of 8.
Yeah. So one cell into a pack of 8 cells, and then 8 cells into 8. Now you have 8 cells, 64 batteries into 8 cells, and then you put those guys in series, and it bumps the voltage up to 24 volts. 3.2 times 8, 24. And yeah, so
there you go.
In that picture, I was trying to figure out how to arrange the pack in a way that would work with my cabinet I was putting them in, with my bus bars. I had to make that's right next to it. That's copper stock. That's 1/8-inch copper stock. I had to get to make the bus bars. I was trying to figure out what's the most economical way, because copper is not cheap.
Right.
So you had to figure out all that stuff.
Before we get to this one, yeah, but just so people listening or the people here, just in case if anybody doesn't know, when we're talking about parallel, thing about parallel makes the battery wider, so there's more amp hours, right? In a way, it's almost, you could think of it like this. This is the analogy. And then series makes it higher voltage. So think about a series like a TV series. Each number goes up. There's more voltage, but you need the amp. So they put them in parallel. So he puts them in parallel first, and then he puts the parallel packs into series to get the higher voltage that he needs to run the equipment and the inverters.
Yeah, there's multiple ways of doing it also. Some guys put it in series first, and then they run them all in parallel. But my final configuration was in parallel.
Nice.
So I chose to do in series first.
And how'd you rope these guys in?
Those are actually two of my really good friends. And we were actually just hanging out drinking beers. And I was like, well, if we're just sitting here bullshitting, they were both on their phones. So I was like, well, if we're just sitting here bullshitting, then you guys are going to help me.
Nice.
So it's actually a really complicated process there. So the bus bar, if you scroll over to a few more pictures, there should be a stamped out metal bus bar somewhere.
There we go.
Yeah, there they are. So those bus bars, my dad had just gone through knee surgery, and I got the batteries. They expand and contract. They expand mostly. They don't really contract. Once they're expanded, that's it. It's called swelling, and so when you get them, certain guys will tell you you don't need to worry about swelling. Some guys will tell you, yeah, you have to compress your battery cells. So I was looking for a way that's going to keep weight down also, as well as not be as much work for me. So some guys use wood. Some guys like make metal enclosures, which is like, I'm not trying to spend a whole day figuring out how to compress my battery pack. So what do? I think, hey, what's that stuff my dad used to make me tape up the garbage bags with? It was fiber strapping tape for like packages and stuff like that with fiberglass filament embedded in the tape.
Ah, okay.
And so we used to have this 1/4-inch stuff, but I looked it up, and 2-inch wide strapping. And you can probably see my hands. Yeah, I have the tape in my hands. A 2-inch wide strip of fiberglass strapping tape has a shear strength of like 650 pounds, and
Wow.
it doesn't expand. That's it. There's no expanding. There's no stretching. None of that, because of the fiberglass within the tape. So I thought to myself, hey, why should I build an enclosure if I can? There's also a clamp on that battery. I don't know if you can see in the bottom right-hand corner, like
Yeah, here.
Yeah. So I clamped the batteries together with that's just like the a squeeze type clamp. I clamped them together and ran that tape around, and I think I went around it 2 times, and that's enough to keep the batteries together. So I did that.
That was a good idea.
Thank you. So I did that with 8 cells to make one 8-pack cell. And then my dad just got home from the hospital from knee surgery. So I said, here, Dad, you can do this. I gave him a bus bar cut to length, but without the holes in it. I said, you got to figure out exactly where to put the holes. And then, so he figured out one bus bar and made a master. And then I went to the garage. I took, we have a metal shear. And I literally just sheared the bus bar at the perfect length there was a lot of those. There was 8 cells. Each cell gets 2 bus bars. So that's 16 bus bars per battery times 3. So what was that, 32, 46? Right?
I don't know.
Doesn't matter. So
Yeah.
I had to make a lot of those, approximately 50 and more to go in between the batteries. So I cut them all to the length, and I had my dad trace out where all the holes went. Then I used a metal punch to punch out each hole.
Yeah, you don't want to drill these holes.
No, that's a lot of drilling. So
Yeah.
now I end up with 50 bus bars. And if you go back to the picture with me and my buddies, so now, like I said, it's still 192 individual cells comprised into packs of 8 into packs of 8 into 3. So I clamped the batteries. I'm also working on cardboard because I found out that granite is an electrical conductor.
No way.
Yeah, it'll short the batteries out.
You must have found out the hard way, dude.
Yep, I did.
Whoa.
So I clamped the
Whoa.
batteries together, put the strapping tape on.
No,
then
it's
I
good you
did
told me that. I didn't know that.
What?
I'm sorry. I'm glad you told me that. I didn't know that.
Yeah, granite's an
Why
electrical.
is that? Because of carbon in the granite, or
I'm not exactly
Silica.
sure.
silica?
Silica?
It'd be the silica in the granite.
Yeah, there's something in it, but yeah, it's conductor.
Whoa, that's amazing.
So I'd strap the batteries together, then I'd give it to my buddy, where he would fit the bus bars onto the positive and negative terminals. Then he would give it to my other buddy down at the end there in the white shirt, and he would put all the nuts on and tighten them down. And so I just took an electric drill and mounted an adapter in it for a 10 mil socket, and I set the clutch to like 2 or 4, something really low, so it's not putting a ton of pressure on the battery.
Wow. This is awesome.
And then that's how we built each 8 individual pack.
Oh, there we go.
Yeah, so that's each cell, essentially.
That's the beauty shot right there.
Yep. And then
That's a good idea, because a lot of people build battery enclosures, and that's a whole other project.
yeah, it's a whole nother project. So if you go to one of the first pictures I sent you, you'll see it in the final layout. Where they're sitting on the counter. They're sitting on a wooden counter and a window.
Here?
Yeah. So if you zoom in on that picture.
Oh, Damien's got a question. How much does each cell cost? Was it about $50?
No, each individual cell, like one of the 192, right?
Yeah.
Each cell cost me $11.
Wow, that's cheap.
Yeah, because you know what? I was looking at used ones and I was looking at new ones, and I emailed Battery Hookup. I was like, look, I'm looking at building a battery setup for my trailer. I need a lot of battery power. What do you recommend?
Yeah.
And so he said, I've got a really good deal coming up on these batteries. And they were Navita's batteries manufactured for the U.S. government, and they were new overstock. I think they were 2 years old, sitting in a warehouse somewhere.
Yep.
So the price was, I think it was $12.50 per battery.
Wow. Just so everybody knows, I've been down to Bensalem, Pennsylvania for Battery Hookup. This guy is so cool. Tom's crazy busy, so sometimes he doesn't answer the phone, but he's got a good sales team. But it's hard to imagine. It's hard to imagine. But just picture if you went to like Costco, but instead of the shelves being filled with food, it's just batteries. And it's literally the entire world is throwing out batteries. They have to recycle them, and that's not their business. So give you an example. Amazon has those Fire Sticks or whatever. If there's a recall or there's a change in tech, every one of those batteries has to be recycled. They can't throw them out. They can't resell them. So they send them the Battery Hookup because he buys them for like pennies. And then he organizes them and resells them to DIYers like Vince. That's basically how it goes. So you're getting crazy deals. Military spec, BMW batteries, Tesla batteries, just helicopter batteries, medical equipment, computer battery backup. Like, it's inconceivable the size. That's why I'm trying to think, like, think Costco, think warehouse, like an entire Home Depot, but all batteries. That would be like mind-blowing, right? Yeah. Did you ever go down there?
I said they were $12.50, but when you bought a case of 30, because they came in their own packaging, Battery Hookup didn't have to repackage the batteries, so they cut you a deal. If you bought a case of 30, you got them for $11 each battery.
Nice.
And then shipping on batteries isn't cheap either. They're heavy and they're hazardous.
Right.
So I'm an hour and a half from Philly, so what do? I go pick them up.
Yeah, exactly.
So I was looking for the most economical, cost-effective way I could get these batteries, and that was, I actually, before I purchased these batteries, I see you looking on is that Facebook Market? Oh, no. I looked on Facebook Marketplace. I actually went up to Boston. I drove 6 hours to Boston to buy some used batteries from a guy that, I mean, it's one of those too good to be true deals. I got up there and they were leaking. They were not the size that he said they were, all kinds of stuff.
Yeah, this is Battery Hookup. The place is huge. And this is not the only one. He's got several warehouses. Some of these crazy cells, the larger ones. I'm trying to show you like the scale of the place, but he doesn't have a photo of like.
No, you're not going to see a picture of the inside.
Yeah. Oh, here we go. Like, so just imagine like wall to wall warehouse size battery situation. You know, it's just unbelievable. And super cool guys.
If I had to put a size to it, I'd say like the size of a CVS, like the big CVS.
Yeah, but that's the one. He's got several warehouses here and in California.
Oh yeah, I didn't see the others.
Yeah, look at the testing facility too. Like, let's say you want to test one of these cells. Like, oh my god! Like here, this is what I have. One of those cells. It's like this. Wait, let me see. You see that? And it looks
Yeah,
like
I was actually looking at those cells. They pack a lot of punch.
Oh my god! Yeah, absolutely. These are the ones that are dangerous, but if you manage them well, you can get a lot of, And it's just crazy the scale of this operation. They get shipments all the time like this, and they have to, dissect this shipment. Anyway, I just kind of I was amazed when I saw stuff like this. I couldn't believe it. Anyway, so going back to, he also sells his own. This, do you know that this pattern is his?
Yeah, I saw that. That's for 13650 cells.
Yeah,
which are really
18
popular.
Yeah, and so, but it's a breakaway, so it's like they're all fusible links, So like,
yeah, it's all nickel, and you can get a spot weld right onto the battery.
Exactly.
That's actually a really good project for like teaching kids in school. I don't know what your limitations are as far as working with batteries, and I mean, they could short circuit it really easy. But
oh look, these are the batteries I needed. Is this a? Oh my god, when was this? I needed this one. Oh, 43 weeks ago. Jesus. I called him about the battery. I needed just one. Look how many batteries he has. Oh my god, this would have been crazy cheap from what I paid. Oh my god. Anyway, all right. So so that's what's going on. Okay, so then let's get back to this. So now this is when you're putting them all together.
That's when I put them all together. So when I did them like that, I actually got 4 blocks of wood. I cut 4 blocks of wood that were like half an inch smaller than the length and the width of the battery. So 2 at the top, 1 at the top, 1 at the bottom, two on the sides. And I use a ratchet strap to pull all the batteries together, to compress it like that. And then I went around all the batteries with probably 5 or 6 rounds of that fiberglass strapping tape again.
Oh yeah.
So I put them upside down on the granite, so that the actual I forget what they're called.
Oh, the terminals?
The electrodes. Yeah, so the terminals were touching the cardboard.
Yeah.
And then I strapped them, and I made a little I used the fiberglass tape to go around the bottom also, to kind of like fully enclose the batteries except for the top.
Got it.
So I fully enclosed them, and then I put the connecting bus bars between the cells to form the actual, from the 8 cells to the 1 battery cell. So you can see there, you can see kind of, if you follow the red thing on the left, that's a battery management system that starts at the main negative.
Which which battery management system did you use? Orion?
No, Dolly. It's one out of China. All these batteries are coming out of China. But Dolly, it's one coming out of China. It's one of the better ones coming out of China. I like the battery management systems, and you can really get lost in those. They can go to thousands of dollars, and they can get really expensive really fast.
Is it Dolly like this?
DALY.
Okay. There we go.
Yep. So I had to wait probably about a month for those to come in, because they actually came right from China. There's not too many people over here that stock those. I was looking at Tom's BMSs, and he actually spoke with them on the phone. He recommended I use that one.
Yeah, he's straight up. He don't care, right?
Yeah.
That guy doesn't. He's never tried to sell me on anything. He doesn't care. You know what I mean? And that's great.
Yeah. And so for the BMS, you got to get a BMS that's suited for your pack as well. So if I bought an 8 I have an 8. My pack would be the configuration would be 8P, 8S, 8 parallel, 8.
Okay.
What's the word I'm looking for?
Let's see. So you'd have your 8P and 8S.
Yeah, 8 parallel, 8 series. So my batteries are going 8 in parallel and then 8 in series.
So you got to
cells.
get something that can handle that.
You need like me. I needed a 24 volt 8S BMS, so it
That
can
would
handle eight cells.
Would that be this one?
It's hard to tell from the thing, but
Okay.
it would just say 24V8S or something like that.
Yeah, that's it. Mm-hmm.
So you got to get a BMS that's configured to your battery pack, and then that one's going to come with 8 wires and one temperature sensor.
Mm-hmm.
So it goes on the main negative, and one wire goes to each cell.
Most positive. Yep. And then most negative, and then everything in between.
Yep. And then I can monitor each individual cell and make sure, like, hey, this cell's getting this much voltage. So, and it steps up too. So the first cell gets 3.2 volts, second cell 6.4, third cell 9.6, fourth cell 12.8, and going up to 24 volts. So you have to make sure that the BMS is very critical. You can run it without one, but you're kind of playing with fire there.
Yeah, yeah. I've run some BMSs before, and you just got to go step by step. The only danger is that you are bringing high voltage away from the pack in a little thin wire, and so you got to make sure those wires are all tucked away.
Yeah. So the BMS limits it. My pack can discharge at the limitation on my pack. The batteries can discharge at 3C, so they can discharge at 75 amps per individual cell. 1C is the amps per battery. So yeah, I can discharge at 75 amps per cell, but the limitation I have is more than 100 amps cannot flow through the battery management system into 100 amp BMS.
Oh, that's good.
That's the first thing. The second thing is my bus bar. You really need like really thick copper that can support that kind of amperage going through it. So like my bus bar can only handle up to like, I think 130 amps flowing through it.
Okay, so you're limited. To pack together, the BMS won't allow more than a certain amount of amps to flow. So even if you short out, that BMS will protect your cells and your equipment.
Exactly.
Just so people listening and people in the room tonight, like when he says 1C, 2C, 3C, a C is just capacity. So if you got a 25 amp hour battery, what that means is if you pulled 25 amps, 1 hour later, your battery's dead. Theoretically, right? That's how you'd say it, right?
That's the so that's your discharge rate. So you can pull 25 amps all at once if you want. The battery can flow that much.
Right.
But that I was just
yeah.
Yeah, so if you had, my batteries, for instance, each cells they have a capacity of 3 C's discharge, so I can discharge 600 amps all at once.
Yeah, that's a lot.
Per cells, but my bus bars aren't rated for that. My BMS isn't rated for that. But that's what the C rating's for. On the
what's cool is that the BMS will limit that or shut it down.
Yeah, exactly.
Which is kind of cool. I have tiny little BMSs that go on 1 cell, or you could have it on 2 cells, and it'll do the same thing. When you go to charge it, if you charge it too high, or if the voltage goes high, or if the voltage goes low, it's better. It's basically a management system that you don't even think about it when you're dealing with a drill battery or a Tesla or whatever. You don't have to think about these things, but it's in there. There's a management system in all those commercial applications.
Exactly.
Yeah, that's cool. Damien wrote something, said that in Western Sydney, they're making a new style battery, no memory issues, no fires, etc. Okay, he doesn't know the material, but yeah, I mean, there's new batteries coming out all the time. But I would say that lithium iron phosphate, it's not always the best, but it's definitely probably the most stable. Yeah. I'm just looking at the.
I haven't done a lot of research, but there is a new, I believe it's called a solid state battery, the newest battery technology coming out that can hold the most and weighs the least because it doesn't actually use any chemicals within the battery. I don't know exactly how it works, but I just heard about it not too long ago.
Yeah. I mean, some of this stuff works in a lab, but doesn't work in practicality. You know?
Yeah.
And you definitely want to get, for an application like this, you got to get something that already is like, that's got years of working ability, type of thing.
So I'm not even done with my batteries. I can't charge them in the wintertime.
Oh, because you need to heat them up.
You can't charge them below freezing, as with any battery, because they freeze. So
Right.
I found these 24-volt heating mats to put under it to keep my batteries warm.
Oh, interesting.
There's so many complications with it, but the satisfaction I get from talking to from being able to have a conversation with a customer, and like people come all the time. People come up. Half of my customers are cars and trailers and Airstream, and half of them are like, "Oh, I see you're running on solar. I see you have inverters in there, all kinds of stuff."
Yeah. So basically, the effort involved is the extra effort, but it's kind of like free advertising. In fact, that's what kind of happened. Airstream is what got me over there. That's exactly, you just described me, the customer. That's how I met you.
Yeah.
The Airstream got me over, and the batteries got me to stay, which then the rest of my buddies bought coffees, and like we stayed, and then you're on the show. Like, yeah, it's free advertising. When you're doing something out of the box that improves the customer experience, I mean, people are interested in that. I think
it's cheaper to run the trailer on batteries also. It's like significantly cheaper to run the trailer on batteries because I don't have to run a generator. So if I had to run a generator, it's probably about 5 gallons of gas a day at $20 for 5 gallons. So $20 a day to run the generator, right?
Yeah.
But the trailer, I plug it in at night. It charges within 8 hours, and I'm paying about $1 to charge a trailer up.
Whoa, it's like nothing.
Yeah, exactly. So, I mean, in the long run, the cost savings of batteries will pay for themselves.
Wow. And what about how long does it last? Let's say you're like, I think you mentioned that you could do the whole day.
I can run 10 hours using my machines. I mean, I can run 10 hours without thinking about power consumption until I'm at 20%. And technically, you can run a lithium iron phosphate battery to like 2% of the floor or something like that. I choose to cut it off at 20%. But yeah, I can run 10 hours and still have battery enough to run my fridge to get home.
And then, how do you know your load? Do you have a battery gauge somewhere, or is it just an app on the phone?
It's an app on the phone, but it goes through a shunt, and a shunt is I'll show you a shunt right now.
This it right here.
Yeah, it's actually in that picture right there. It's a little blue thing in the corner.
Yeah.
If you can zoom in on that, there's 3 batteries that can go into that, and everything going. Yeah, the batteries aren't in this picture, but everything going to and in and out of the batteries goes through that shunt, and I'm able to monitor how much voltage the batteries are at, how much amps it's drawing, how many amps it's charging at. So, like when I plug it in, it shows me that I'm charging at 16 amps at 530 watts or something like that. And when I'm discharging, it tells me like, hey, you're pulling 70 amps at 24 volts or something like that.
Got it.
And
That's
then
awesome.
Just to the left of that, I have a fuse block that's actually for car audio. But it takes 4 A&L fuses. I'm only using 3. It takes 4 A&L fuses at 100 amps each. And then that goes to my main DC switch. And then if you guys are following this, from the main DC switch, there's 2 wires going down, 2 red wires going. There's 1 red wire going in, 2 red wires going out.
Yeah, this one.
Yeah, that wire goes to my 2 inverters, and there's a small red wire coming off the input that controls my that controls all my DC stuff. So that goes to a DC to DC step down converter, and it takes it from 24 volts to 12 volts. And for
That's
right now, my trailer's running on 12 volt lights that draw 3 watts per.
It's like nothing.
Yeah, it's like nothing. So I can run the trailer can run on 24 volts without the 120 volt system being on.
That's awesome. Yeah, and this DC to DC charger or step down, it's kind of like an electronic alternator in a way.
I don't exactly know how those work. I didn't do too much research on that.
Well, just like, what would you do? Like what happens is when you convert a gas car to electric, you lose the alternator, but you still have to have 12 volts to run all these controls in the car. But you need a big traction pack, a high voltage pack to run the motor, but you still need the 12 volts. So what do you do? So you tap off like you did here. It's the same setup, and you step down to 12 volts. Now you can still run your radio, your whatever you want to run, and all the controls are run that way as well. So it's funny, you got the same setup. You basically have built an electric car, except instead of using your high voltage pack for traction, you're using it for coffee.
And my high voltage isn't even that high voltage. 24 volts is like nothing.
Yeah, that's true. It's pretty low. Yeah. With a car, you'd probably need at least 48, but most of the time it's between 96. That's the lowest, I would say. And then 144 is a pretty good amount. But then Tesla does 400, and then Porsche is doing 800. But once you pass 144, you really it's just pack configuration. You don't need the higher voltage is higher RPM, but you don't quite need that. What you need at that point is like torque and a light car, stuff like that, aerodynamics. Other factors come in, Cool. And then you got a box here. This is standard 110 box coming off the inverters, right?
Yeah, the inverters put it out, and the inverters, 2 of them together, I can run split phase. But right now I have it set up for 120, and they go into the box, and then the box splits it up. I got six breakers in the box right now. Only 5 are used, and everything in here is on a 20 amp circuit. So like the fridge and the grinders are on a 20 amp circuit, even though they only pull like 8 amps combined. Coffee maker's on a 20 amp circuit, but that only pulls 12. The espresso is on its own 20 amp circuit that pulls a full 20, and my point of sale is on a 20 amp circuit, but that only pulls maybe 1 amp. But when I was building this thing, I had an extension cord running in, but once I got the electrical system in, I started running power tools off my electricity in here.
Oh, right. That's awesome. So imagine, there it is. So this is probably what Bloomquist would want to know. Can you run power tools, and can you charge up your power tool batteries?
Yes, I can. I can run power tools. The power tools I can run though are kind of limited. I wouldn't try to run like a big motor power tool in here, like a big 3/4 drill or a right angle drill or something like that, because the electric motors have, you probably could, because my grinder has a massive electric motor, but electric motors, when they start up, they have a very high amp draw. Even though if they call for 1 amp, they could draw 6 amps starting or something like that. So that could put a strain on my inverters, and that's where the inverters, like when I was shopping for the inverters, there's high frequency and low frequency inverters. These are high frequency. They have MOSFETs that kind of hold on 1 second, straight. I have to close my vents.
No problem. This is cool. So just real quick about going back to the battery tech. This is Damien sent me this. This is a possible new type of battery, zinc bromine flow battery. Is that right, Damien? Okay. Yeah, I mean, there's so many things coming out, but but if you're just buying stuff from the recycle, like if let's say Matt wants to do something, I would just get it from Battery Hookup and have them shipping them out there. There's a competitor to Battery Hookup, which is it's called Big Battery in California, and that
Yeah,
guy's
but they make new ones.
oh, okay, I got
If any of you guys in the New Jersey area want a battery to like teach a class with, I bought 20 individual packs out of a medical thing, and I just strung them together in parallel and in series just to make a practice pack before I built my big pack. If one of you guys wants it, because I don't even know what to do with it at this moment.
I mean,
It's just in my desk.
I'm teaching batteries, but I have batteries. I don't, if someone else wants it, but if you got no takers, we are going to do some stuff because we got 2 electric cars at the school that we built from scratch.
How would you charge them? Does
What
it
was
come
that?
with a charger? How do they?
No,
how would
you have
charge
to figure out your own charger system. So it only the peak. There's 3.7 volt packs ran in series 4. Yeah, you could charge it with that. That thing's about $40 on Amazon. It takes forever though.
Yeah.
But there are 3.7 volt packs ran in series of 4 for like I think it comes up to like 14 or 17 volts. But you can only run like really small things. Like you can run like an LED light because each individual cell has a BMS on it, and the BMS will trip if you draw too much voltage. So like I powered a small fan with it, and just like silly little stuff. You can't draw any like you might be able to charge your phone from it, but anything more than that, any higher amp draw, the BMS on each pack will trip because it's protecting the battery from over voltage.
See what I
But
did
it's an
here.
extra-
Oh God, sorry. See what I do here is these are 18650s with the BMS wired onto it, and then what's nice is that it's protected from overcharging, it's protected from discharge too low, and also it's protected from too much draw and too much charge. And it's super cheap to put these together. I could show people how to do it. But I'm trying to make a project out of it. And, you could run, if you, 18650 has, that's the size of the battery. It has 3.7 volts nominal. You charge it up to 4.2. So you put them together, you got over 8 volts. So now you could take that, you could use it for like a little toy car or something like that. But right, like you said, it's complicated. So it's like, what are you trying to power? And then you have to think, if you need 12 volts, then you have to make a combination of series to get there. But if you need more amps, then you got to go parallel. So this is all new, but I promise you, I'm playing around with this. I promise you it makes perfect sense, but not when you first get started.
when you first, very confusing.
Yeah.
Very confusing.
Yes. But don't you feel like before you were rambling off numbers and stuff like it? You're like, it takes this many watts, that's power, that's SP. That you totally get it now, but when you first start out, it doesn't even make any sense because it's not a piston. You know what I mean?
Yes. Yeah, exactly. So there's Ohm's law comes into play a lot.
Totally.
Batteries. Yeah. So like a battery, like the voltage of the cell, 3.2 volts times the amp hours, 25 amp hours. If you multiply 25 by 3.2, you get your total pack wattage. So that's like 75, almost 80 watts per pack. And then you just do that on a larger scale to get the entire wattage of the battery. And then you could figure out your power consumption. So like with my setup, I have approximately 15 kilowatt hours. The inverters draw approximately 1 kilowatt hour while they're running, and then the rest of the power, 14 kilowatt hours, I have to use with my electronics. but you got to figure that out from each cell. So 80 watt hours times 192, and you get your total pack watt hours. And then it's a lot of math, but it's a lot of basic math. You can only go in certain numbers. So like 192 is not a random number. I can only build if I want to run 24 volts. So I need minimum 8 cells per pack to run 24 volts. And then you can build up from there, but you don't really want to build up in odd numbers with batteries. So it's a lot of math, but it's a lot of very simple stuff.
Obviously there's a lot of info, but there's two chemistry voltages. There's 3.2 nominal, and that's lithium iron phosphate. And then there's 3.7 nominal, which is lithium ion.
Yeah.
So the amount of batteries you'll need are totally different because it's two different chemistries. And the chemistry, the difference between the metal inside the battery is the potential difference, and that's what gives you the different voltage. But there's a lot of support out there. It's just not popular the way like a gas engine would. You like carburetor or valves, like it all makes sense. But like this is a 18650 charger, and what it does is it also will tell you capacity. So it'll discharge it, bring it back up, and then tell you how much was transferred during the down and back up, and then that's your capacity. Actually, just in the down, it'll let you know it'll bring it all the way down first, and then it'll bring it back up. And in I forget which direction, but probably up. But it'll tell you, this is how much it holds. So now like on a used cell, you could find out what's really left in that battery as far as like capacity goes, because they deteriorate. Anyway, that's like a whole battery lesson. That's a whole different podcast. That's like that's like a whole school you could do. Okay, cool. Let's see. So, all right. Well, it's kind of like off the battery topic. Did you have to learn about coffee? Like, how do you know about coffee?
I don't really.
You needed it to stay awake to build all this stuff. It just
I don't actually drink that much either.
My mind is blown right now. I feel like
I feel like my students
put me in the grinder.
I feel like my students are like, what the hell was all these numbers about?
No, honestly, you know what? We should have started. You know what I would say? Everybody here has drill batteries, and you got one that's dead. Don't throw it out. Take it apart. That's got this inside of it. It's got these 18650.
It's got 18650 inside of it, and then you can power other silly stuff with that. Like you can just get like a little LED from Radio Shack's not around anymore, but you can just get a little LED and that'll power, and then you can run in series and it'll make it brighter.
Yeah. So you're already doing this. You just didn't realize it, but it's in the drill batteries for sure.
Yeah, I've taken apart an old Milwaukee one before because I was going to try to repack it. I saw how to do it, but I can't remember if I got the wrong size, like the actual size of battery, or if I think I cracked the casing getting it off, because getting those casings off is about impossible.
It's not easy. You have to take like an X-Acto knife and a sheetrock knife, and they're in there tight.
Yeah.
There's also mods. So let's say you get an old drill and the batteries are dead and you can't get a replacement. You can get a modification clip that will accommodate 18650s. You can make your own packs if you wanted to, or you could recycle some other pack. It's pretty cool.
I never thought about taking them apart. I've run things off of, like, I've run alligator clips from the drill batteries and just showed the kids, how things work that way. But I never thought about taking them apart. I really never did.
Have you seen when people take battery or drill batteries and hook them up to little kids' little type Jeeps and stuff?
Yeah.
You have to put like an inverter, otherwise it it takes off flying.
Yeah, the drill batteries have it.
The only reason I decided to take one of my batteries apart was because I dropped the drill and it landed on a screw puncturing one of the cells. So I had pulled it apart to see
Oh.
how damaged it was.
Mm-hmm. Yeah, they pack a punch. So there's a lot of amps in those. And then if somehow they went dead because you got either they got abused somehow or whatever, but you don't have to throw them out. Yeah, you could totally take it apart. It's gonna have a BMS. It's gonna have a bunch of 18650s. They're either going to be soldered together or spot welded together with a strip. They might have a fuse in there. I wonder. I don't know. And then what you can do is you could use the clip part, recycle that part. So be careful when you're taking it apart. Like, don't destroy it. But then everything else is up to you. You can make a whole new box. You could have a super pack. It'll be a little heavy though. There's so many ways that you could do this, and the configurations are up to you. You really could do higher voltage if you wanted to, or whatever. Yeah, I've got a whole bunch of these. Yeah.
For my potential project, and these guys know every time we have somebody on here talking about batteries or whatever, like for me, so I would use it to, obviously, we have a mobile classroom. We did a lot what you did, just not with an Airstream, obviously, but, tore apart a trailer, rebuilt, and all that stuff. We would want to charge our batteries, like our job site batteries. The mobile classroom just has simple LED lighting down the middle. It does run my computer, modem, printer occasionally, but then I also have like a mini fridge in there and a microwave, and then the mini split is what heats and cools it. Is that something? And like for us, the idea would be like the hook it up solar as well. Is that something like? Am I even in range of what you got going on there as far as use? Like when it comes to power usage, all that stuff. Like even though I build houses, I when it comes to electrical, I understand how to hook things up, but the electrician has to tell me to use these wire gauges, all that and stuff, because I like all the numbers behind it. I'm definitely not where you're at.
So you have a battery pack in the trailer, right?
No, we hook it up to our tent power pole.
Oh, okay. Yeah, you could definitely build a battery pack to power the trailer. You have to get solar. Like I have solar on here. I have 400 watts on the roof, but solar is not gonna really do much for you. It's like a drop in a bucket.
Gotcha.
Pretty much, unless you have this massive solar array. I mean,
Yeah.
Everyone talks about solar this, solar that. Unless you have like the really efficient panels and like a lot of surface area for the sun to hit, solar's not really doing much for you. I mean, my 400 watts on here, it's only giving me 400 watts in full sunlight, and even then, it'll probably keep my lights on and my fans. That's it. It won't even power my inverters. I have flexible panels, so they put out much less. But even the really good panels are nominal. As far as a mini split, air conditioners take a very large surge when they start up. So you could actually run it with batteries and a low frequency inverters. The inverters that invert the DC to the AC power, like I have high frequency because they were like what everybody recommended for off-grid living. But a low frequency inverter, they're probably 80 to 100 pounds, but they have probably a 60-pound transformer inside that holds a lot of voltage for those surge loads, like starting up your air conditioner. I really should have one in here because my coffee grinders, they have a big motor, and so they take a high surge when I turn them on. So I'm probably killing my inverters little by little. But you want something like that for running power tools. Like you could run like an impact gun on that, a compressor probably, even a welder.
Well, for us running tools, we don't even do everything's battery powered. Our miter saw, our table saw's not, but we could get a battery powered. But we plug in a tool when we use our small air compressor when we're shooting on siding, or if we have to plug in our table saw on the job site. Everything is batteries, all batteries. So we're literally we'd be using batteries to charge batteries.
Yeah, there's nothing wrong with that. You could do it, but just one thing to know is that your inverter will consume power.
Gotcha.
So it's usually not much. I think mine take like 100 watts each, but that's something to keep in mind because 100 watts each per hour. That's one inverter. That's
If it's 10 hours, it's
2,400
1,000
watts
watts.
at the end of the day. That's if you're running for even 10 hours. That's 1,000 kilo. That's 1 kilowatt hour. That's a significant amount.
So
Yeah,
and then
sure.
so how do you charge your battery? Like how does that all charge up? I think you talked about. I've also been kind of halfway doing something else here as I'm listening.
I
Kids
talked
popping
about
in
it
and out stuff.
briefly. The way
Because I know
my
you guys talked
inverters
about
are set
charging
up.
batteries. I just didn't know how yours. What?
So
No, we
for
got
coffee
you.
shops,
He's going to tell you.
for coffee shops, most espresso machines run on 240 volt split phase power. So when I was choosing my inverters, I wanted something that would possibly be able to run a larger espresso machine. These inverters also tick that mark. So they can run. I forget the term, but they can run together to create 240 volts. Okay, so I have 4-gauge wire coming in to charge. AC voltage goes from like a regular outlet into my inverters, and then they charge my batteries from it. I have 4 wires going to my
Oh, wait.
inverters.
Just sorry to interrupt. Just to be clear, your inverters are actually the chargers as well.
Yeah, they're the chargers as well. Yeah, so once you get into the higher end inverters, they're chargers as well. You spend $200 more, but you don't have to get a separate charger, and it really
That's a cool
simplifies
feature.
Yeah,
That's a really cool feature.
Well, and wouldn't that take up less space than having an extra thing, right?
yeah, exactly. It
all
takes up
one
less
shot.
space, uses less wire. They're also the solar charge controllers as well. So that's
oh,
one
wow.
less thing you need.
That's 3 features.
Yeah. But they draw power consumption. If you go everything separate, if you have a separate solar charge controller, separate battery charger, and a separate inverter, then the inverter uses much less wattage, probably only 20 watts or something like that, and you save power, but it's a nightmare having to wire all that stuff up. These are very simple. You get your power in, your power out, and your communication cables. That's pretty much it.
That's cool.
But as far as charging it, I have 4 wires going to each inverter. So 3 wires going to each inverter, but 4 wires coming in the trailer. So I can charge off split phase if I really wanted to. Right now I charge off a 20 amp, 120 volt outlet, just a regular outlet charged up in 8 hours from my typical 50% discharge. If I discharge to around 20%, which is happening a lot more recently because I'm getting these bigger events, that takes me probably about a day and a half on 20 amps at 120 volts. If I bumped up to 40
Later,
amps,
Tim.
time and half.
Very cool. So even if we had temporary power on the job site, would we be using less energy just by plugging in, like every night, plugging in, let things charge when we come back, then run everything off batteries? Is that?
Yeah. I don't
And
know
then
what
all
the
we'd
rate
be
is for the
sure.
I don't know what the rate is for the power at the job site, but if you plug it in at home and it charges up, you're essentially it's a battery. You're just storing energy to use it somewhere else. That's it. Just like a compressor battery, or
and that's even assuming we use the whole batteries during a day. Some days
exactly.
we don't even have to charge batteries.
Some of my mornings events, I use 30% of my battery, so I can go 3 days before having to charge this thing. I charge every night, but once you get to a large battery bank, and the shunt that I have on, that's the only kind of like name brand thing I have, but it lets me monitor from my phone exactly how much battery power I'm using. I use during the day, how much I have
one
left.
Did you get?
I got the Victron. It was about $100.
Victron?
Yeah, Victron. Victron shunt.
Okay.
That's like the most important piece of like data logging thing I have.
Oh, I see. This is cool. Yeah, they're actually starting to do shunts that have CAN bus. So I don't know if you know, but CAN bus is like communications within the vehicle for like modern day vehicles.
Yeah,
That's
this one has that feature also. If I had like the
oh,
Victron inverters and stuff like that, but Victron stuff is 4 times as much as the inverter I have. I mean,
yeah, wow,
that's like top of the line. But
yeah.
this was kind of a but that's the Victron I have.
I picked it out.
So any power that goes in or out of the batteries has to go through that, and that keeps a monitor on it.
That's the monitor. So Matt, so like something to think about is this, right? Like you're kind of like, well, we have power, but would it be worth it to still have a battery? I would say yeah, and here's why. I don't know how they sell you electricity out there, but in California, they charge you a different bracket for a surge, or how much you use in a daytime hour versus a nighttime hour. So what the battery would do is like it's almost like eating a little bit of sugar or eating a like one cookie a day for like a month versus eating 30 cookies at once. If you eat 30 cookies in a day, you're going to be sick. But if you had one cookie a day, it's not a big deal. You see? So it's the same thing. Like if you take all your power during the daytime, they're going to charge you for it. But if you have a battery, you could have charged up all night and then use that battery. You charge at night for the low cost and over time at under 20 amps or whatever it was. And then during the day, you could surge. It doesn't matter. That battery is going to give you what it can. Obviously, within a limit, it's going to have a protection. But so that would help. Yeah.
Yeah, because I'll have to look to see if I don't know if we have any peak things on our bills. I've never really paid attention. And then because, like I said, for some days, though, I mean, like right now we're working on the foundation. We're not charging anything. I mean, only thing it's doing is the air conditioner's running inside the mobile classroom just to keep it cool and stable. Otherwise, I mean, we're not doing anything extra. And here's the thing. If we have outlets on the outside of our mobile classroom, so like for example, they had to use their concrete guys had to use their hammer drill, and they plugged it in. Well, we can just plug straight in the mobile classroom, and they can pull off they could pull off that off the hammer drill stuff. I mean, assuming like I said,
yeah, in your situation, like, see, a battery's kind of like a project, right? So like, but it doesn't have to be. Because you could buy, they now sell, they call them power packs or whatever, but they're basically generators.
Yeah, solar generator.
Solar generator, that's it. And so it's no longer like it's normal to look for these everything that Vince did, you can buy as a unit, but it's not going to be made exactly how he wanted it, and also it'll be expensive.
Very expensive. If I had to build this battery pack, just the batteries alone would be like $15,000, and I'm into it for like $4,000. By the time I got like the batteries, the materials, the inverters, everything, and 15 grand is just for the batteries. They charge Battleborn batteries. If you look them up, they charge for a 1 kilowatt hour battery, 12 volts, 100 amp hours. They charge $1,000.
It's called Battleborn
batteries, and all their batteries is a bunch of 18650 batteries. I mean, there's a lot of research and development into it, and someone's got to pay for their time, but
yeah,
it's very expensive to buy a pre-made battery.
Yeah, because they're doing the work.
Well,
yeah,
so
exactly.
I have a like the monitors that you can hook up to your panel box for homes and stuff. We have one. I just hooked it up to the mobile
sign.
Ours is Square D provided us, Schneider Electric.
Oh, okay.
I forget what ours is called. Anyways, we don't have the internet hooked up to the mobile classroom yet, so we can't do anything with it at the moment. Like, I mean, I guess I don't know if it records. It may record without the Wi-Fi, but it's not
a watt meter.
Yeah. And so here in a couple of weeks, we should have the Wi-Fi hooked up, and it's all hooked up and ready to go and stuff. So I'm going to monitor, see what we're using, where we're using, and I'm going to try to get people anytime they plug something in to plug into the mobile classroom instead of to the outlets on the temporary pole, just so we can monitor and see how much we're using, like truly now. Because like I said, we've talked about this before. The big problem we run into where we spend a lot of money is we use a temporary electric heater inside the house to cut the chill when there's nothing. I mean, you're literally heating the outside world because it's escaping and stuff. But that's really where we spend the big bucks. But
they draw a lot of power.
Yeah, and they do. And I mean, they're not meant to do that all the time, right? I mean, that's just they're temporary again. And
yeah, that's like my espresso machine. They pull solid 15 amps continuously, and that's a big power draw.
You could, on a simple level, just to mess around, you could get one of these. It's called a kilowatt, and it's a monitor, but it's just one plug. But you can type in your energy rate. So you could put in the rate at your local whatever, and then it'll then tell you like what it's going to cost you to run that piece of equipment as it monitors it over time. So I'm running a dehumidifier in the other garage because it's crazy humidity here, and you ruin the interior if you leave it in a concrete garage. And so like it really like spores start to grow, like mildew. It's disgusting. But if you keep it dry, it won't start. But I was like, how much is this going to cost me? Because I'm going to run this thing all the time. So I put this thing on there, and I'm up to like $20. And I'm like, all right, that's worth it. It kind of puts. See, the problem is we've been thinking about gasoline. So you think like miles per gallon. You think cost of what does it cost per gallon? You got to start thinking in kilowatts. You got to start thinking about how much it costs you per kilowatt, and also watt hours. The watt hour is like, if you're using something and it's 1,000 watts for an hour, that's 1,000. That's a 1K hour. So you got to start thinking in these terms, and you got to monitor it. So like you said, you want to monitor it so you know what you need, because then you don't know how big your pack's going to be, like what you need exactly.
Yeah, you want to know your power consumption before you build it.
Bam, power consumption.
Yeah, and see, that was kind of and these guys have said that to me before, so that was the whole purpose of taking that thing and getting it put on there and start going for a year here and see where the numbers are and see what it'd take. And it's something that would really, because the idea behind it, like I said, the school, when I told them, I'm like, hey, I'm looking into potentially, maybe this thing is either, battery powered or solar powered or combination of something, or anyways, getting off the grid a little bit more. So our temporary power consumption is even less, because even if it saves us a few months of not hooking the temporary power up, or it saves us all the way to the time we put our actual meter on that, and then we get even if it's during construction, but we're able to commission the furnace inside the house. Okay, well, maybe that's the route to go. We never even use temporary power.
Down here the whole time? I thought you fell asleep. Oh.
Sorry, guys.
It's all right.
No worries. Usually my kids are the ones coming in here yelling.
Tell them there's no coffee at night. There's beer. Are you closed? Is that a customer?
Yeah, we're closed right now.
So Bloomquist also is getting into passive houses and modern building techniques. And this is like, bam, this is like right up the alley. So like power consumption of a passive house has got to be a lot less than a regular house. And then I'm sure that, that network you have is, dealing with this. They're trying to reduce the amount of consumption, and they're trying to monitor it. There's got to be somebody that's doing off grid, and that's the same thing that you're trying to do. So it's all. Yeah.
I was gonna say, yeah, you're totally right. Like, heck, they monitor everything. I know a builder who has sensors in the walls it'll give them the moisture content. And so what they do is like the batteries will last for like 10 years or something, and it connects to the Wi-Fi, and so they'll build the house and pass it on to the owner. They'll be pulling data off these houses and what's going on inside the wall cavity with these probe sensors that are they connected inside the wall and like stuck into the wood or whatever. Yeah, these guys, some of these guys are getting data on everything. It's insane.
Wow, that's cool. Yeah, I mean, one day your house will be self-sufficient. And the other thing is that a lot of the mobile applications, like for instance, so I'm sure Vince, you got to pull this thing with a vehicle, right? But imagine if your vehicle had a pack. That pack's going to be huge.
Yeah.
You know, it's like
Like the
100
new F-150 Lightning.
Yeah, there you go. If you had the F-150 right? That's I don't know. I'm gonna guess 100 kilowatt pack probably, and then you're not going to use all of it driving, so you use it to power the trailer. Yeah. Did you get on the list for the Cybertruck? Maybe you can pull. That would be greater for pulling you, right?
No. I gotta make some money first.
Oh, okay. Cool. All right. Well, this is pretty good. We're over the time, and I mean, we usually hang out, but I'm going to kill the recording because we kind of did 2 hours already. But this is pretty good stuff. Anybody want to add anything?
I got one more question.
Oh,
So
dude,
look,
go ahead. I always forget.
You're done selling coffee for the day. You pull into your house. What do you plug it back in? How do you charge the batteries?
I plug it back in as soon as I get home. I have the trailer's got a 30 amp 120 volt plug on it. I have an adapter that cuts it down to just to a regular 15 amp plug. I'm pushing a little bit. I run it off a 20 amp outlet. My inverters can only charge at 10 amps each, or they can only charge in increments of 10. So like I can charge at 30 amps, but I have to double that to so it'd be 60. But so long story short, I charge at 10 amps each inverter, 20 amps, and I just plug it into a regular outlet, but it's got 20 amps feeding it instead of the normal 15.
Nice.
And then you go for the next day.
And then I'm good for the next day. And that's if I run like 6 hours or less. If I run a bigger event on my current charging situation, sometimes I won't charge all the way up for the next event. So like, for instance, Let East, right? They told me I couldn't move my trailer, so I set my trailer up Thursday at like 2 p.m. I ran all day Thursday, and I ran halfway through Friday before I killed my battery. So essentially, a whole day, 10 hours. And then I had to bring in a generator to charge it. But if it doesn't charge all the way up, I'll use it on that 70% charge until I have to charge it. So, like this coming weekend, I have an event all day Saturday. If it kills my batteries enough to where I can't charge it in time for my event on Sunday, then I'll go to my event on Sunday with whatever battery I do have. I'll run that event, and I try not to schedule myself for like 2 10-hour events back to back. It happens sometimes, but it is what it is. I really could. This thing could charge at 60 amps per inverter, so like it could charge in like 3 hours the entire battery, which is insane. But where are you finding 120 amps? Like 50 amp split phase is like what you get around here, and that's like
turn everything off in your house.
Yeah, exactly. So
and here's go ahead.
Yeah, I mean, I'm really slacking on the part where I have to install a more powerful outlet to charge this thing from. But that's really my only limitation right now.
And here's kind of like, the obvious question. Someone will say like, oh, well, I forgot my question. Damn. Basically, I forgot what I was going to ask you. Let's see. You come back, you charge, and then I forgot what I was going to say. I just lost the question completely.
I can run the trailer while I'm charging also.
Oh, there you go. Okay.
Yeah. It will, the way the inverters are set up though, it will trip the outlet if I'm pulling more than 20 amps. Because if you're running it while it's charging, it sends, like, if you're only running a 5 amp machine, it sends the other 15 amps to the batteries. But if you pull more than that, it'll trip the outlet, depending on what you're plugged into. If you're plugged into 100 amps, you're not going to trip it. It'll just divert all the power to usage instead of drawing from the battery. But
so like when you're on site, they might have a way to plug in.
yeah, if I'm on site and I can plug in, I'll use their power. The inverters will use their power first before pulling battery power.
Oh, that's amazing. So it basically does a lot of the balancing for you. This
It
is
does
really
almost all of it. You can change the settings to pull from the battery first until you're 30% discharge, and then pull utility power. But there's a whole lot of settings you can change. These inverters, they're really well optioned for the price that they are.
That's cool. Okay, I remember my question. Something someone would ask. I already know the answer is probably no, but like, do you see a major spike in your home energy bill?
Not exactly. It's gone up by about $40 a month, probably about $1 a day, a little more.
That's
Not,
like nothing.
not significant.
That's
Not the
amazing.
amount of power I'm using in this thing.
Because the thing is that it's even so. If you got an electric car, you might see a higher spike. Traction, moving a vehicle down the road, takes way more power than what you're doing. What you're doing is stationary power. And even though you're running these industrial things like coffee makers and stuff and pumps, it's not even near what a vehicle would need, right?
They're not using continuous power. So like the espresso machine, it pulls 20 amps for 15 minutes while it warms up, and then it cycles over and it pulls nothing. Maybe an amp while it monitors its heat level, and then it says, hey, you got to warm up again. So it cycles on for 2 minutes, maybe even less than that, then it cycles off. So my actual power consumption, once everything, I remember before I was talking about if I turn everything on all at once, I could overload the inverter and make it go into surge power. But once the hot water heater is on and it's warmed up, it doesn't really pull any more power. The espresso machine, it only pulls power if I'm drawing shots from it. And the coffee machine, it's only pulling power when I'm making coffee. All right, right now nothing's on. But during the day, if we're sitting around waiting for a customer, we're not really using any power. The lights, but the solar on the roof compensates for the lights being on and the fans running.
So going back to Duke for a second, power consumption is kind of like when you guys do the robots and when you do your drone stuff, like it's the same problem. It's just smaller. Let's say you got a robot and it has too much power consumption, or you don't have enough battery, that thing will lose its battle because they didn't scale it the correct way. So it's a similar problem. It's just smaller.
Yeah, that's a lot of the discussion now is the batteries in those robots and the drones. You only have like a 15, 20 minute battery life. Then you got to charge it again. So especially with the drones, they use so much power because they're also running on GPS. So they're taking in like the GPS inputs and they're trying to stay straight when the wind is blowing. They have to stay in that one location and they're just draining that battery.
And they don't turn off either. There's no idle with a drone. It's just run.
Yep, full speed. It's just going.
Yeah, it's not like an airplane. There's no gliding. If you're not on, you're falling.
Yeah, exactly.
Yeah, like a 2-stroke, all or nothing.
Yeah, that's funny. All right, cool. Anybody else got anything? Otherwise, we'll kill the recording here. This is pretty good. All right, well, yeah. And when's your next gig?
Tomorrow afternoon, Union Farmers Market.
All right. Cool. The Coffee Stream, New Jersey. Everybody check them out. Very cool, Vince. I think it's great what you're doing. And I can't wait to see the next project. You're probably going to make a whole van. That'll be awesome.
Yeah. Next project is a 50s Grumman delivery van.
Oh, hell yeah. Yeah. And that's aluminum, right?
Aluminum, so it'll look just like the trailer.
And are you going to do an electric motor, or are you going to do it just electric
That's gonna
setup?
be a gasser. Just
Okay.
I don't know. All I thought about is the look of the van so far. Can't look
Yeah,
like
that's-
everybody else's stuff.
That's cool. Yeah, you got to get some good sign painters.
Yeah,
Or do
I
it yourself. Okay, cool. Thanks for joining us. I know there's a lot of time and you're getting ready and you have a business, so it's always go, go, go. I really appreciate you doing that. Shop Class Podcast. Check us out every week, Wednesday, and this recording will be up on the YouTube channel. All right.